welcome to a new season of Earthrise. I'm Ndoni Kanyile here in the Seychelles to find out why saving these creatures is so important.
And I'm Juliana Schatz in Massachusetts, USA, where circuit boards and soldering irons are sparking a revolution in environmental technology.
Our planet is currently facing the greatest extinction crisis since the dinosaurs disappeared 65 million years ago. We're losing species at 1,000 times the natural rate, and within this loss of biodiversity are species that are often extremely unusual and represent a significant amount of evolutionary history. I'm Ndoni Kanyile in the Seychelles to find out how a global movement is trying to save some of the most endangered and distinct species on Earth. When we think of endangered species, we often imagine large animals like rhinos, tigers, and pandas. But we're losing species across all parts of our ecosystem, with potentially catastrophic results. The Zoological Society of London has set up the Edge of Existence program, which aims to protect almost 2,000 of the most distinct and endangered amphibians, corals, and mammals on the planet. The Darwin Initiative funds the project in the Seychelles. Hi, Charles. Which amazingly is home to 12 of these species, one of which is the Sicilian. So what is a Sicilian? I'd never heard of them before.
Well, Sicilian it looks a bit like worm. Some of the locals even think of it as a snake, but it is neither. It is in fact an amphibian. Okay, it lives in moist area. It's got vertebrae like frogs.
And why is the Sicilian specifically a part of the edge species?
Well, the name edge itself means evolutionary distinct, globally endangered. So Sicilian falls into that category of distinctive animal.
On the evolutionary tree, some species like the dog emerged only recently and have many close relatives. However, others like the aardvark and Sicilian, which have been evolving independently for many millions of years, have few close relatives. They represent a larger amount of unique evolution. If they disappear, there will be nothing like them left on the planet. Species are scored on their evolutionary distinctiveness and on how globally endangered they are. Those that score highly on both counts are considered to be edge species, marking them out as an urgent need of protection.
So for you to conserve something, you have to know what the species are and where they are found. But as for Sicilians, you have to go digging for them. You don't hear them, you don't see them.
Oh.
So we don't hit straight like that. We might kill it, so just sort of, want to have a go?
I'd love to. You trust me.
Be my guest, be my guest.
Kill one in my first try, seeing as they're so rare. The Sicilians we're searching for exist only in the Seychelles, and so Charles's work is vital if we want to understand why they're heading towards extinction.
Yeah, sometimes you can dig one whole day, you don't find anything at all. Here's one.
Oh, wow, it's so fat. Look at that.
Want to hold it?
Gosh. Oh, wow. It's so strange to think that this has a skeleton, a vertebra. Wow. So let's put it to sleep so we can work with it. The Sicilian is anesthetized briefly to allow Charles to study it. It's fighting the good fight. Higher up in the mountains lives a group of the smallest frogs on the planet called the zyglossid frogs. Hi, James.
Yeah, hi.
You made me work for it today, eh?
If you could help me with that.
This way? Very little is known about these frogs, and with the smallest of them measuring just 1 centimeter in length, James really has his work cut out. How does this data help you? Explain to me.
This data will help me to understand where the frogs prefer, which kind of habitat they prefer. Whether they prefer areas where it's always damp, wet, or they prefer dry areas.
Because if you know what they prefer, you know where to find them, but also you know what kind of habitats you need to protect to protect
and
the
also,
frogs.
we'll know where most probably the frog will be in the future. So we need to understand a bit about the habitat where they are now. When you're doing the search, you have to be very careful not to just put your hand in. You might get bitten by centipedes. Might get bitten also by centipede.
By a centipede.
Or you can get bitten by spiders.
I thought I saw someone jumping. Was that it, or was that my imagination?
No, it is.
It is.
Oh, I found one here.
You got one?
Yeah.
Let's see. Oh, wow, that's tiny. That is unbelievable. So a species like this
Yes.
would date back to almost when Seychelles was a part of...
A part of the Gondwana. That's about 65 million years.
65 million years
ago.
That's incredible.
And us, we have just come up in this island less than 250 years. With all the destruction that we have caused over the years in Seychelles, we need to conserve and protect the species.
Oh, look, I lost it.
Yeah, all right.
It jumped off. As quickly as we found it, it's gone again. While the Seychelles Islands are famous for the beauty of their coral reefs, they too have faced huge threats. Coral bleaching, where an increase in the temperature of the oceans bleaches and kills the coral, was responsible for the death of around 90% of the country's coral in 1998. But a concerted effort to protect and regenerate the areas seems to be paying off. So if you had 90% damage, how long does it take for those coral reefs to regenerate?
It depends on the species of corals. So we've had a lot of bouncing back of branching corals, especially, which grows really fast, establish the reef, and the other species come back. The fish comes back grazing on the algae, so that allows for the other coral species to really come back. That's why we're having really good reefs.
Really reinforces the whole idea and the importance of biodiversity and why it's so important.
Exactly, and it also reinforces the idea of this whole network thing, that everything works together.
Bana's found a good spot where she can go down and measure about 100 square meter area of coral. The coral that Silvana is most interested in is the Physogyra lichtensteini coral, which is listed as vulnerable to extinction. Her research will help inform the local diving and fishing industries, as well as assisting in the development of marine protected areas.
We're going to do some statistical analysis on the data. From there, we're going to work on a report for the government, making some recommendations on different conservation strategies that could work for.
So this data that you collected today could actually influence policy.
Exactly.
Seeing this coral in its environment, what strikes me is that you cannot protect these edge species in isolation. This coral exists as part of an ecosystem, with each element of the marine life contributing to the whole. The same can be said about all the edge species in the Seychelles and around the world. Genetic diversity is vital in maintaining these healthy ecosystems, and the work of the team here in the Seychelles and similar teams globally is providing hope that these most distinct species on the planet will survive.
Environmental pollution is a growing problem in many parts of the world, with companies making headlines for illegally dumping toxic material into local ecosystems. In the United States, offenders face hefty fines if caught, but local communities often lack the evidence and resources to challenge companies who they suspect of polluting their air and water. I'm Juliana Schatz in New Orleans, Louisiana, where an innovative network of hackers and hobbyists are developing low-cost tools to help citizens fight back against polluters.
It's been a difficult decade for the city, with large-scale environmental disasters such as Hurricane Katrina and the BP oil spill devastating people's lives and local ecosystems. But out of this onslaught, new groups have emerged to tackle environmental problems. One organization is called Public Lab.
Hey, how are you?
Good, how are you?
Good.
Public Public Lab is a community that works to create the space for people to share open source environmental tools, technologies, and resources. It got started in response to the BP oil spill right here in the Gulf. So this is sort of the founding location of Public Lab.
As the oil spill unfolded, BP was accused of stopping journalists and scientists from documenting the disaster.
Not being able to actually understand what was going on was a big issue.
In response, a small group of mapping enthusiasts got together and started using low-cost balloons and kites to get aerial images of the oil spill, and Public Lab was born.
Hi, Jeff. It's Juliana from Earthrise. How are you?
Its 7 founding members are spread across the states, part of a growing global community of thousands of hackers, coders, and campaigners whose aim is to put the tools of environmental activism in the hands of the citizens.
I mean, starting with sort of balloon and kite mapping, there were other things that came up, like people would come across residues on the beach, or dead fish or animals, or tar balls and things like that.
This is collected off the shores of Louisiana?
Yeah, just after the BP spill. And the idea was to come up with a cheap and quick technique to analyze this without having to rely on expensive testing or a laboratory, and to be able to say, yes, this is crude oil, and even better would be, yes, this is crude oil from the BP well. And we were like literally Googling, like, how do you identify oil? And we learned that you could use a spectrometer, and so we began building them.
Spectrometers are specialized pieces of kit used to analyze chemical makeup of a given sample. They can cost up to $100,000.
This is actually made of a pizza box, and there's a piece of a DVD that's had the label peeled off. And if you look through it, you can see the light coming through this narrow slit at the other end. And that's a spectrum of light.
Great, I see it.
The most primitive example of a spectrometer you can imagine, I guess besides like what Newton made or whatever. This is sort of a refinement where we're trying to stop random light from coming in at different angles. And then this is the first one that was like eventually began to ship to people. And we put a webcam in the corner, and you'd be able to take a picture of the spectrum and analyze it. You should be able to tell, this is crude oil, that's actually motor oil, that's unrelated, it's not actually oil at all.
Several versions later, they had developed a marketable product reaching lab quality technology,
But this one has everything built in inside with the webcam in there.
as well as a cheaper $10 version.
You can actually just download the PDF and print it out yourself and build it. And you fold this up and tape it onto a smartphone or a webcam, and then you can turn your phone into a spectrometer. And
That's amazing.
Data can then be uploaded to a spectral workbench, an online forum built by the Public Lab community for further analysis and dissemination. The blueprints for these gadgets are also online and totally free for anybody to modify for use, anywhere.
people around the world face similar pollution issues, even if it's not, the same exact crisis. I guess there's sort of this international network of people each contributing a little bit of the total puzzle.
Here in Boston, Don Blair is an active member. He has a PhD in physics, which goes a long way when tinkering with circuit boards.
Is this your office space?
This is one of my offices. This is one of my several offices. So I have been working on the open water project at Public Lab, where we're trying to make open source hardware for water monitoring. A lot of the designs now are shared online, and this is one of the circuits that we're working on. So I edit this circuit and add new features, and then I post that online, and then other folks in the community comment on that, make their own additions, and then we send it off to a factory and have it produced somewhere.
This circuit board is designed to detect chemicals in water. If they can make it small and cheap enough, he and a host of hydrologists think it will be useful for documenting pollution in oceans and rivers. Tonight, Don is running a workshop to see if they can tweak the design. But first, he needs some dirty water to test.
We have our professional water sampling containers.
Is this how all the technical hydrologists?
Yeah, that's exactly how the professionals do it.
Right.
In this room is the collective intelligence of years of Ivy League education. They've come together to brainstorm new possibilities for Don's water testing device.
We're going to be building some circuits that are related to water monitoring stuff. The idea is that with open source hardware, we've been working on a design for a water monitoring device that can fit inside a recycled water bottle and for weeks, maybe months, monitor some of the most common water monitoring parameters like temperature, conductivity, depth.
The circuits we're building tonight measure conductivity. Don wants to test them on the dirty snow we collected earlier, which he knows will be salty because it's from the recently gridded road. The higher the salt levels, the higher the conductivity.
1 cream, 1 sugar, Dunkin' Donuts, coffee.
Oh, God.
That looks like the proper amount. Now the cleaner snow. This one's,
Yes.
In another scenario, you'd have much more controlled samples.
This is down and dirty prototyping.
Yes.
Down and dirty prototyping, got it.
So the higher the frequency, the higher the conductivity. That's just how this circuit is designed.
Okay, so dirty snow, cleanish snow. Ready? Okay. Ooh, it works! The sound is really gratifying.
Yeah.
Okay.
Connect that to a microcontroller and an SD card, put that out in a river, leave it for a long time, go and retrieve it, and then look at how the conductivity changed over time. In New Orleans and in other places, they're interested in saltwater intrusion. Sea level rise is bringing the ocean closer to a lot of communities that have been relying on fresh water. This would be a sort of low-cost, accessible way of monitoring those things.
This is part of a larger movement to empower local communities to test their water. I mean, what do you guys think about that?
One of the difficulty for water quality modeling is the lack of data. So if we can have like those sensors with such low cost, we can definitely have real-time monitoring of the rivers and multiple locations, many locations, and we can have like more data for models that can produce better predictions.
Public Lab's tools are being used to monitor industrial pollution in Spain, document forest loss in Peru, and even detect air pollution in some of Ukraine's national parks.
Today we think a lot about cell phone cameras in terms of justice. You know, are you allowed to film the cops to see if they're abiding by the law? So I think, you know, in a similar sense, in the environmental space, I think that small, inexpensive sensors, you know, could be transformative in a similar way.
This super simple, super DIY approach means that in the future, virtually anybody might be able to document damage being done to their local environment. Back in New Orleans, Stevie is taking us to see some of Louisiana's wetlands. The wetlands are a natural defense against storms, protecting the millions of homes in the Mississippi Delta.
Essentially, this whole area was a wetland and now is open water. All these were once trees. All this was, you know, marsh grasses and birds and all kinds of things. And now, I mean, you can look out and see kind of what it looks like over there. And this whole site looked more like what's across the way there.
Many people attribute this loss in part to the activities of coal, oil, and gas companies based along the delta. Canal construction has contributed to wetland destruction by allowing salt water from the Gulf to enter freshwater areas, killing off plants and vegetation.
So how is Public Lab working in this area?
So we'll use the balloons and kites and poles to collect aerial images. You know, if you can capture the imagery, it can help tell the story of what might be causing these things to grow or to not grow.
How are you?
Hey, how are you doing?
I'm Juliana.
Scott.
Nice to meet you.
Hey, how are you doing?
What are you doing over here? Flying the kite.
Well, yeah, flying the kite. This is my near Earth satellite. I'm part of a group, the Gulf Restoration Network, that's advocating that the city spend some of the fine monies from the BP disaster on these urban wetlands as infrastructure to keep people's homes and properties safe and free of water.
Yeah.
A Public Lab community member made this plan, this 3D print. I bought the kit from him and assembled it myself. One of these old Canon cameras from eBay is hacked, and then we have a normal RGB camera.
What did you call these? You called these low-end satellites?
Near Earth satellite.
Near Earth satellite. How's it gonna fly in this wind?
You know, well, maybe too well.
Today, Scott is flying his infrared camera over urban wetlands to monitor water levels and plant health.
There goes the camera. Look at that. It works so well.
The infrared allows a very clear marker between land and water, which is sometimes pretty ambiguous here in New Orleans.
The red area is the water, and the white areas are healthy marshland. But it's not just the infrared. Scott also uses aerial photography to gather evidence of companies he suspects are illegally polluting the water.
We've been able to monitor some of these polluting fossil fuel terminals, some of these coal terminals that just dump in the Mississippi River all the time. They were spilling so much that the spillage was accumulating in a pile on the riverbank. So that showed multiple consecutive days of violations, which means a lot legally. So the kite picture really kind of convinced everyone that we could show that this company was being criminally negligent and just not taking care of their own products and not taking care of the river, which is ours.
Scott now runs workshops to share his knowledge and empower a new generation of activists.
Public lab aerial photography helps me as an advocate give a tool to people on the coast to see their own landscape. I have a luggage scale here to measure the lift. Like it needs to be twice as much as the payload, roughly. I'm gonna zip tie.
Wouldn't want to be the one responsible for losing the balloon.
Many of today's participants are from coastal areas across the state and want to use aerial photography to fight their own environmental battles.
You're waiting for it to pop?
By giving everybody a tool to monitor their environment and challenge big companies, Public Lab is putting the power back in the hands of the people.
Heads around it so that it doesn't hit the ground. You do this.
All right, I am letting go.
All right, so it's like going kind of fast.
Whoa!
Kind of like how astronauts reached the moon and they saw the Earth for the first time. They saw it as one. Even people that live on the water and never comprehend the travesty that are these old oil fields.
By 2050, if nothing is done to protect the wetlands, it's predicted that Louisiana will lose a staggering 700 square miles to the Gulf of Mexico, 1/3 of its 1930s coastal landmass.
How would the photography help you?
I'm from a town called Homa. It's about 30 miles north of the Gulf of Mexico. So this is the kind of thing that I think would be really useful for the people of that area to understand these concepts, to kind of save themselves, basically. Like they're from a place that should be and statistically will be gone within 10 years.
It's a sobering thought, but maybe the images collected today will be part of a growing body of evidence that will empower communities to advocate for change, protecting wetlands, and perhaps to help stem the tide of this coastal erosion.
I know. It's almost like sailing. Yeah. But you got the right hat on. I kind of want to read it.
Once online, these pictures form a growing data set that clearly documents changes to the area. What Public Lab have created is not only access to tech, but a space for grassroots activism to grow.
To hold government and corporations accountable, you need to put, these documentary tools, low-cost tools, in the hands of people who are most affected.
It's a good thing for advocacy because you can have this data that you collected yourself, that you did yourself, even taught how to do, and use that to make a lawsuit or make a case against someone, or to do something to actually protect yourself instead of just talking about it, I guess.
We could feed the world twice over. We just waste food alone, let alone how much food is being produced and grown around the world.
Ships are only allowed to have 0.1% sulfur in the fuel.
When I started here, we could smell, when the bunker barges were here loading, it was a smell, but now nearly nothing.